Lesson 23, looking at section 9.9 and 9. In this particular situation, operations of power series. Now, there's something very important about these particular power series. Okay, we're going to use a series that we already know, and then we're going to create a power series out of it. So, if you take a very close look at this one right here, okay, if you recall the geometric series is a times r to the power of n, where r, okay, this thing is convergent if r is less than 1, okay? What does it converge to? This thing right here, okay? Now, keep in mind that this is review. Right here is nothing new, okay? However, if you look below it, if we replace the r and scratch out the a, if we replace the r with an x value, what happens? Well, now I have the summation of x to the n, which is equal to 1 over 1 minus x instead of 1 over 1 minus r, and this is convergent on absolute value of x less than 1, okay? Meaning that the power series, this thing right here, this power series, is convergent to this function, okay, on the interval from -1 to 1, not including 1 and -1. Again, the reason why those aren't included is because if I try and plug those in, I'm going to have some problems, okay? So, the next question is to find a power series for f of x equaling to 4 over x plus 2 centered at 0. Now, the way we're going to do this, I'm going to go ahead and write this out. Number 2, I'm going to look at f of x equaling to 4 over x plus 2, okay? I want to rewrite this particular function, okay, I want to rewrite this particular function so it appears as the geometric function, okay? So what I'm going to do is I'm going to rewrite this as 4 times 1 divided by x plus 2. That's the first step, okay? Next, what I'm going to do is I'm going to take this thing, okay, this bottom piece, so that it looks like 1 minus x. Now I'm writing it way over here, okay? That's what I want it to look like. Well, how can I make this look like this? Well, let's first start by changing the order. So I'm going to change this to 4 times 1 over, 2 plus x. Next thing I want to do is I want to make this value a 1, okay? Again, x can be anything I want it to be. I mean, heck, x can be x over 7, x to the power of 2, x minus 12, as long as this x value, okay, manipulates, and I get 1 over 1 minus something. This is what I want it to look over, 1 over 1 minus, and I'm going to go ahead and just block this in. I want that to be something. I don't know what I want it to be, but we'll find out here soon. How do I make sure that this is a 1? Well, why don't I factor out a division of 2? Okay, why don't I put in here a 2 over 2? By doing so, I can now factor out the 2 and the 2 from those two pieces. This becomes now 4 on the outside, 1 divided by, factoring out a 2, 1, when I factor out the 2, plus x divided by 2. Well, that's getting closer, okay? Now I have 1 over 1 plus something. Okay, now let me go ahead and pull that 2 out all the way. I do 4 divided by 2 and I get 2. And this is 2 times 1 over 1 plus x over 2. Now, how do I make this right here a subtraction sign? Well, I can rewrite this as 2 times 1 over 1 minus a negative x over 2. Again, all I'm doing is I'm manipulating it so it looks like 1 over 1 minus something. That's my something. Okay, so I'm going to hold on to this particular function. This is the same thing as this function right here. Exact same thing. Now, what do I know? Well, I know that this function right inside here is the same thing as this function here, with my x being slightly different. So this x is slightly different. Let me replace the x here and this x here with the same x that's right here. Okay, so this is now 2 multiplied by the summation as n equals 0 to infinity of x, my new x being negative x divided by 2, to the power of n. Again, this is my new x, that is my new x in the summation. Okay, so I want to know what the power series is. This is it. This is my power series. Okay. The other question would be maybe where does it converge? Okay. For what values does this converge? Let me zoom out a little bit so you can see it. To that function f of x. Okay. So for what values does it converge to that f of x? Well, the original one converged when my x value is less than or equal to 1. Absolute value less than 1. Okay. Well then, my absolute value of x, my absolute value of negative x divided by 2, should be less than 1. Well, the absolute value is going to allow me to eliminate the x, so I'm going to have, the negative, so I'm going to have absolute value of x over 2 is less than 1. If I multiply both sides by 2, the absolute value of 2 is still just 2, so these are going to cancel out, and I have the absolute value of x is less than 2. If this is true, that means I'm going to write it up here right next to the function. Okay, this thing right here is equal to the summation n equals 0 to infinity of negative x divided by 2 to the power of n on negative 2 to 2 with, again, the radius r equals 2. And then that comes from down here. Okay? So that covers example number 2. Again, I'm utilizing a previous series that I have to find a new one. Okay? Let's go ahead and look at the next one. It says find a power series for 1 over x centered at 1. Okay, well, let me go ahead and flip this page over so I have some more room here. Number 3. Okay, I want to know what f of x equals 1 over x. Okay, now centered at 1 is kind of a misnomer. It's leading into something, but it's unnecessary for us to actually work with. Okay, it's kind of forced to be what we're going to play with. Now, what I want to do is I want to write this thing as 1 over 1 minus something. Okay, that's what I want to write it as. How do I get this to be 1 over 1 minus something? Well, this is going to be equal to, how can I get 1 minus x? Well, first of all, I can write it as 1 over, what if I added 1 and subtracted 1 at the same time? Okay, let's go ahead and look at that. Now, if I've done this, okay, and I want this to be 1 minus something, okay, I need to manipulate what I have here to work that out for me. So what if I just threw parentheses around this stuff here, okay, and maybe factored out a negative 1? Again, if I factor out a negative 1, then I have 1 over 1 minus a bunch of stuff where these are now different values. The x being the negative value now, and the 1 being positive. Okay. Well, wait a second. Isn't this centered around 1 now? Again, I mean, it's some x value plus a 1. This is centered around 1. Okay, and you'll notice that this is the same thing as the summation as n equals 0 to infinity of, based on our geometric power series, okay, x, which my x is now 1 minus x to the power of n. Huh. That's it. That's the so-called series. Okay. Now, if this is the series, okay, well, then what would be the radius of convergence? Okay. What would be my radius, and what would be my interval? Okay. Well, for the radius, we remember again that it's 1 minus x absolutely has to be less than 1. Okay. Well, if that's true, then my radius is still 1. The x plus or minus something is still less than 1. Okay. Well, this also means that I have 1 minus x is less than 1 but greater than a negative 1. By manipulating this thing, multiplying each piece by a negative 1, flipping all the signs, okay, I could actually subtract the 1 first. I'm going to do that first. That's going to give me negative 2 is less than negative x, which is less than 0. And then I'll go ahead and multiply everything by a negative 1 and flip all the signs. So I have 2 greater than x greater than 0. There's my interval. my radius will be 1. Okay, what's the distance between 2 and 0? What's a value of 2? I divide it by 2 to get my whole radius. So my radius, r, is 1. Okay, again, the absolute value of something being less than a number. And then my interval is 0 to 2. So that covers, again, basic manipulation of power series in order to get a new power series for a different function.